So this video is for absolute value. This is about solving absolute value equations. It's an introduction to the concept of absolute value, and then using those concepts to solve equations involving absolute value. So let's take a look. Well, first let's define what absolute value is and what the notation we're going to be using is. So the definition for absolute value, we use these two straight lines. If x is greater than or equal to 0, and the opposite if x is less than 0. Now, sometimes people find this confusing, and I understand why. But if you think about it, if x is greater than or equal to 0, like say it's 5, that means the absolute value of 5 is just going to be 5. What if x is less than 0? Let's say it's negative 3. This says the absolute value is negative 3, which is positive 3. So this is kind of a convoluted way of defining absolute value. It's a lot easier in application to think of it as just throwing away the negative sign. All right? The absolute value always comes out positive. Why? Well, it's defining a distance from 0. Okay? So the distance between positive 5 and 0 is 5. And the distance between negative 3 and 0 is 3. So that's one way to think about absolute value, is that it's a distance from 0. Another way to think about it is with this technical definition here. And another way to think about it is to just throw away the negative sign, okay? Because an absolute value is always a positive number. All right. So now, what if we have an equation that involves absolute value? So for example, on this assignment, problem 2 says the absolute value of k is equal to 14. The standard way to approach an absolute value is to split it into two pieces and say there are two ways this could happen. If k were 14 or if k were negative 14. Okay? And you can try any of those definitions we just talked about and see that it works on both of these answers. Absolute value of 14 is 14. Absolute value of negative 14 is also 14. We could draw a number line. Both of these numbers are a distance of 14 from 0. And if we apply this to it, you'll see the absolute value of 14 is 14. And here it's negative 14 or positive 14. Okay. Let's see here. What else? Problem 4, we've got absolute value p minus 5 equal to 13. So again, p minus 5 could be 13, or p minus 5 could be negative 13. Once we get that set up, then we can solve. Add 5 on both sides here, and p equals 18. Add 5 on both sides here, and p would be negative 8. So there's our two answers, 18 or negative 8. You can plug them both in and make sure that they work. What else? Now the key to doing these problems is to not split this up until this absolute value is by itself. So on the first page of this assignment, that's always the case. So let's see, let's skip down to problem 12 here. Here we've got absolute value 2x minus 9 equal to 18. So the absolute value is by itself. So 2x minus 9 could be 18, or 2x minus 9 could be negative 18. Okay, and then we'll add 9 to both sides. 2x would be 27. Divide on both sides by 2. X would be 13 and a half. Over here, add 9 to both sides. What is that? Negative 9. And so x would be negative 4 and a half. So there's our two answers. 13 and a half or negative 4 and a half. Okay, what else? Let's see here. Let's look at problem 16. Absolute value 2 minus 5 halves m equal to 14. Okay, so this is by itself. We can go ahead and split this in half. And however you want to approach this is up to you. You can move this over here, move the 14 over here, or we can move the 2 over there. But if we do that, you've got to not lose that negative sign here. And then again, you can divide on both sides by negative 5 halves. I'm going to multiply on both sides by negative 2/5. So this all cancels out and we get m. Over here, we get negative 24 over 5, which is fine as an answer. If you're afraid of fractions or something, we can call this, what, negative 4.8. That's also fine. Okay, you can call it negative 4 4/5. Those are all acceptable answers. Okay, let's do the same thing over here. Negative 16. And then again, you can divide on both sides by negative 5 halves, or you can multiply on both sides by negative 2/5. So this all cancels out. And over here we get what? Positive 32 over 5. So that looks like 6.4. You can leave it 32 over 5. You can call it 6.4 or 6 2/5. Those are all acceptable answers. So we get this and this. Okay, now the problems on the second page are a little bit trickier because you have to get the absolute value by itself before you do anything. So in problem 18, 3 times absolute value 5 minus 2x plus 1 equals 10. All right. So this is, you need to treat this like a variable almost. Almost like it's, you know, like 3a plus 1 equals 10. And you want to get that a by itself. Okay? So we're going to subtract 1 on both sides. That'll leave us with 3 times absolute value 5 minus 2x equals 9. And then divide by 3 on both sides. Now we've got the absolute value by itself, just like those problems on the first page. And so now we're ready to split this in half. 5 minus 2x equals 3, or 5 minus 2x equals negative 3. Okay, so we can subtract 5 on both sides. Negative 2x is negative 2, and that says x equals 1. Over here, we get negative 2x equals negative 8. Divide on both sides by negative 2. And so x could be 4. So x could be 1 or x could be 4. Either way, we'll get an answer of 10 from that calculation. Okay, let's see here. Problem 22. We start out negative 4 times 6x plus 1 plus 9 equals 1. Okay, so again, we want to isolate this absolute value the same way we did in problem 18. So we're going to subtract 9 on both sides. Get negative 8. And then divide on both sides by negative 4. And so we get absolute value 6x plus 1 equals positive 2. We've got the absolute value by itself, so now it's time to split it in half. 6x plus 1 equals 2, or 6x plus 1 equals negative 2. And then we just have to get the variable by itself. In this case, x is 1/6. Again, if you want to make this a decimal, that's fine as well. But I'm kind of a stickler for repeating decimals and expressing this correctly. And so if you're going to express it as a decimal, please do put the bar over that. 6x equals -3. And so on this one, x is -1/2. And do reduce your fractions or express them as decimals, one or the other. But don't just leave them unreduced. Okay. All right, let's look at a couple more here. What else do we have? Okay. Let's see, let's go ahead and do problem 26. And I think that'll do it for this one. 12 times 1/3 x minus 3 plus 8. And then that equals 32. All right, so again, we want to get this absolute value by itself. So, subtract 8 on both sides. Over here, that'll be 24. Divide on both sides by 12. And that'll give us 2. Okay, now the absolute value is by itself. Now we can split it into two pieces. And we can say 1/3 x minus 3 equals 2, or 1/3 x minus 3 equals -2. Okay, let's get the x by itself here, so we want to add 3 on both sides. 1/3 x equals 5. And again, you can divide on both sides by 1/3. I'm going to multiply by 3, and so we get x equal to 15. Same thing here. Let's see, that'll be +1. Multiply on both sides by 3. And x equals 3. So x equals 3 or x equals 15. Okay, so that's the basic idea in working with equations that have absolute value in them. And I think that'll do it for our first week of assignments. I think I'll wait for week 2 to talk about absolute value inequalities. So that's where we take the ideas of inequalities and put them together with the ideas of absolute value. And it's a little bit tricky, but we will talk about that next week.